Industrial pipe systems operate at the edge of physical limits, moving volatile materials under extreme heat and pressure. In this environment, any failure under pressure can trigger a catastrophic chain reaction across the entire facility. To prevent this, carbon steel pipes are internally lined with corrosion-resistant alloys, like Inconel 625. This specialized weld overlay, or cladding, acts as an indestructible barrier between the fluid and the structure. True mastery of this process requires more than just applying the metal. You must be able to prove the integrity of the bond without ever making a destructive cut into the pipe. This workflow requires an angle grinder for surface prep, a MIG welder with Inconel 625 wire for the overlay, and a specialized non-destructive testing kit, including an ultrasonic gauge and dye penetrance. Getting this cladding right prevents environmental disasters, extends the operational life of the hardware, and removes the need for frequent, expensive repairs. Preparation is the most critical phase. You must strip the carbon steel surface down to bare, shiny metal before any welding begins. Achieve this by grinding, wire brushing, or sandblasting. The goal is the total removal of all mill-scale, rust, and surface oil. When working with galvanized steel, you face the additional threat of liquid embrittlement caused by residual zinc. If zinc remains on the surface, the intense heat of the weld burns it into the steel grain boundaries, causing immediate microcracks that can compromise the entire structure. Even a microscopic layer of dirt or zinc will ruin the bond of the Inconel overlay, making the cladding project a failure before it truly starts. Once the surface is pristine, you can begin the gas metal arc welding, or MIG, process using the Inconel 625 filler wire. As you lay down the weld, you must fight a metallurgical phenomenon called iron dilution. As the arc melts the metals, iron from the carbon steel base pulls into the Inconel layer. A single pass can hit 12% dilution, causing rust. Applying a second weld pass caps the contaminated layer, keeping surface dilution below 5%. To minimize this mixing further, calibrate your machine to use lower heat and maintain a faster travel speed during the weld. Precise control over iron dilution is the only way to ensure the Inconel maintains the chemical resistance needed for harsh environments. After welding, the pipe enters a furnace or wrapped in thermal blankets, heating to between 600 and 1000 degrees Celsius. This heat cycle addresses the severe internal stresses created by localized cooling of the weld pool. Post-weld heat treatment, or PWHT, allows this molecular tension to relax, stabilizing the bond. This data displays the micro-hardness distribution across the base metal, heat-affected zones, and the weld metal itself. The thermal bake lowers the hardness and significantly improves the overall impact toughness of the cladding. Skipping this thermal phase leaves the pipe looking perfect on the outside, but extremely brittle and likely to crack under operational pressure. The operation concludes with non-destructive testing, which provides the final proof of the weld's integrity. Use an ultrasonic thickness gauge to map the exact depth of the cooled weld overlay. Your compliance window is narrow. The overlay must measure uniformly between 2 mm and 5 mm to meet industry standards. A layer thinner than 2 mm will eventually corrode, while exceeding 5 mm wastes an expensive amount of raw Inconel. Next, use dye penetrant testing to scan the surface for any microscopic flaws. This is a 3-step process. Spray on the penetrant dye, wipe away the excess, and apply the developer coating. Red dots or lines indicate the developer is pulling trapped dye from hidden cracks. A successful test shows a completely white surface with zero bleed-through. More advanced projects may require X-ray diffraction to measure internal stress, or deeper ultrasonic scans to check for internal voids. Rigorous testing provides the evidence needed to certify a pipeline component for high-pressure service. Confirming a uniform 2 to 5 mm thickness alongside a clean dye test marks the completion of a professional-grade Inconel overlay. Success in this field relies on preparing the bare metal, managing dilution, relieving internal stress, and verifying the results through non-destructive testing. These same cladding principles are used for heavy storage tanks, flanges, valves, and plates across the global oil and gas infrastructure. Controlling these variables, heat, cleanliness, and rigorous testing, secures the integrity of the entire industrial infrastructure.